everybody. Today is Friday. It is day 13. And what we're doing is we're doing Chapter 8, Section 1 today on buoyancy and fluid. So the first thing I want to do is I want to show you the one-pager. So the one-pager has to do with, first of all, defining what a fluid is. Well, back in class, when you had me for chemistry, we knew that that a matter is definitely made out of a solid, liquid, or gas, right? So, setting my timer. So, the define a fluid is the ability to form or alter their shape, solid, liquid, or gas. But in Chapter 8, we're going to talk about mechanical, liquid, and gas. Liquid has a defined volume, but gas does not. Gas has no defined volume or shape. So when you're putting a liquid in a container, it assumes the shape. When you are putting a gas in a container, it will escape out and go wherever the boundaries are of that. So for this, density and buoyancy forces, we have mass density is mass per unit volume in a substance, which is the letter P, which is RHO. The formula for that is P, which is mass density, equals mass divided by volume. SI units is kilograms divided by meters cubed. Gas is compressible, but can have a density over a wide range of values, so they have a table that we have to look at. Buoyancy force keeps things afloat. Buoyancy force also is fluids exerted upon something, a force, an object that is partially or completely submerged in water. And when you have a buoyancy force, it is always the opposite of gravity when we're doing our diagrams. Weight is an object is immersed in a fluid, and that is the apparent weight. So it gave you Archimedes' principle, and based on that is if you had a fluid with the spout on it, and you filled it up to the spout, it would not go into the other container. But as you lower the weight, which is changing this displacement here, the water will go out and go into the other cup. The more further it is displaced, the deeper in the cup it is. Buoyancy force is FB equals FG, which is displaced, which is MFG. Magnitude of buoyancy is the weight of a fluid displacement. FBF of a floating object. So whenever we're trying to find the buoyancy force of a floating object, we will actually need to use this answer. So this is force, buoyancy, equals FG, the object equals MOG. And the buoyancy force is the weight of the floating object. So that's my one-pager. So then the next thing I have my sample problems. And on my sample problems today, we just basically will take the information and chug it in. So the sample problem that was on in the book, it was talking about, says a bargain hunter purchases gold crown at a flea market. After she goes home, she hangs the crown from a scale and finds out the measurement is 7.84. She then weighs the crown while immersed in water, and the scale read 6.86 newtons. Is this crown made of pure gold? And explain. So here's where we get the information up here. And so now what we're going to do is we are first of all choosing the equation situation. Then we're rearranging and isolating what we need to have. And then after we do that, then we're going to put it into the formula. So our formula, and what we're doing is this section right here. So what we're doing is we're taking our 7.84 and subtracting our 6.86, and we're getting 0.98 newtons. What that's going to tell us is that is going to tell us our force buoyancy. Okay? So then what we're going to do is we're going to take our 7.84 divided by our 0.98 and times the 1.0 times 10 to the caret. So, looking at our calculator. So the first thing we want to do is we want to look at our node, mode. We want to take it off of degree. I need to have it in radians. Let me make sure I did that. Yep. Do I need to have it in scientific? Yeah, let's go ahead and put it in scientific because I do see this answer right here, and that means it's a very small number. So I'm going to do alpha y, enter. I'm going to do 7.84 over 0.98 over, open bracket, 1.00 times 10, caret 3, and then I'm going to go over and close my bracket, and I get 8 times 10 to the third power. Okay? So, now what we're going to do is we're going to go into the problems that we have on page 277. So the first one says, it says a piece of metal weighs 50 newtons in the air and 3.6 in the water, and 41 newtons is the unknown liquid, and find the density of the following the metal. So the first thing we're going to do is we're going to find the metal. So the first thing we're going to do with that, is we're going to go and we're going to do our equation. So based on this, we're looking for the metal. So we're going to do our alpha y, enter, and we're going to do open bracket 50, close bracket, open bracket 1.00 times 10, caret 3, over, close bracket, down 14, over, and enter, and I get 3.5 times 10 to the fourth power. So then the next thing I'm going to do is I'm going to go over here. And this one here tells me that I'm trying to find B, which is the unknown liquid. So for this one, I'm doing alpha y, enter again. I'm doing 9.0, close bracket, open bracket, and then I'm going to do 3.57 times 10 caret to the third power, over, close bracket, down 50, and then over and enter, and I get 6.42 times 10 to the second power. And so that's my answer for number 1. Number 2 says a 2.8 kilogram rectangular air mattress is 2.0 meters long. That's the length. That's what that L stands for. L stands for length. Okay? When a truck pulls on it, when a truck pulls on it, in a 0.100 thick. So it is 2.0 meters wide. It is 0.500, and that's going to be my width. Now, I'm going to change my meters, and I'm going to put a dot here because I have to have that. And then it says 1.100 meters thick. Okay, so I've got my mass, my length, my width, times my height. And it says, what is to support the water before sinking? So I have to find the P for the water, which is on the other table, and my gravity, which is 9.8. So then what I'm going to do then is I'm going to try to find for what big M is. So to be able to do that, I'm going to do 1.00 times 10 caret 3 over close bracket, open bracket 2.00, close bracket, open bracket 0.500, close bracket, open bracket 0.100, close bracket, and then I'm going to subtract because that's what it says here. This is the equation that I'm doing, okay? And it tells me that I need to subtract 2.8 from that. And so when I do that, I get 970E1. So I'm going to do mode. I'm going to change this back to normal. And if you put that 9.72E1, that would have been fine. Or you're going to put 97 kilograms. Okay? So for number 3, it says a ferry boat at 4.0 meters wide, okay, 6.0 meters long, all right. When the truck pulls on it, the boat sinks to 4.0 centimeters in the water, okay. What is the height of the truck? So to be able to do that one, I'm going to do this equation right here. So to do that, I'm going to do open bracket 1.00 times 10 caret 3, close bracket, open bracket 4.0, close bracket, open bracket 6.0, close bracket, open bracket 0.0400, close bracket, open bracket 9.81, close bracket, enter, and I get 94176. And if I change this to a mode to scientific, and that answer would be fine, I would get 9.4 times 10 to the third. Okay? So, this right here is your practice problems. I'm going to try to, this weekend, to go over your quiz and your test and send it back to you. I'm going to send that to you individually so that I will grade it online. Please reach out to me if you have any questions. I just want to make sure that you are doing what you need to do. We have until the 15th of next month to get as much as we can covered. Please make sure you stay on track of everything. Text me, ask me questions that you need, and I hope you have a good day.